So when I were asked to show you some frame development, do a live coding for these integration steps, I asked myself what would be necessary to start. I will give you an overview about frame common components. I will show you why we need something like this. I will clarify some wording. We have heard about frame and container and component and things like this. I will try to clarify this. If you're somehow confused during my presentation, just tell me that I need to clarify what I'm talking about, whether it's the application or the component or whatever. We have heard about the API. I will also give an overview about the building blocks we have in the FDT container to show you what is necessary. If you have clarified everything, we will start with live coding. As Mr. Knierim has had a half an hour to speech and was half an hour on top, so my speech is about 2 hours, 2 hours on top. We will see when we go to lunch today, okay? If you have any questions, signal me. If I'm too focused on my machine, make it a little louder, okay? So first of all, we have the frame common component. FDT has decided for interoperability reasons to have something that could do it well. The same is for DTM development for FDT2 DTMs. The frame common component should do the same for FDT1 DTMs. You should not have a lot to do with the FDT workflows, the interfaces that need to be called and things like this. It should be wrapped somehow to make it easy for you. The next possibility, the next advantage is that with a frame common component, it should be able to integrate FDT in almost every system, in almost every application. Still, as a frame developer, you should not handle the complexity of FDT. So finally, the FDT container component from M&M software was chosen as the FDT frame common component. We have a product series named FDT container at M&M. This is a FDT container application where the DTMs are hosted in, and you could do the project management and the topology management and everything else. And we have the FDT container component, which is the runtime level. So if I'm discussing with my colleagues, we are sometimes just talking about a container, and I need to ask, are you talking about the component or are you talking about the application? Just to get clear. As we have seen in the presentation of Mr. Kniering, there was just written frame. Frame means the application, the FDT container application. Have you heard that I said FDT in capital letters? Makes a difference. And the runtime frame or the component is the FDT container component, the frame common component that does all the FDT work for you, all the workflows. So if we are looking about the responsibilities that are somehow in all this environment when building up an FDT container application. FDT, capital letters, okay. The FDT container component, which is the blue box right here, is the specification conform implementation of all the FDT workflows that need to be considered in an application. As we have seen in the presentation of Michael Heller, this could also be an application with almost no GUI. Well, command line is also some GUI, but you don't need to be. You don't need to have some nice look and feel or whatever. So all the FDT container, all the FDT workflows are done by the FDT container component, which reduces the effort to implement an FDT frame application. There is a structured API, which gives you access to the catalog, telling you which DTMs, which device types are installed on the system. Also, the project and the topology is provided you by an API. You have an interface you need to call, and you get the information. There are also proxies building you or showing you the DTMs, and the proxy is some kind of version independent. You don't need to bother about whether it is a FDT1 or FDT2 DTM. There are some data type converters doing the job for you if there is some interaction done. Interaction manager as well, one of the parts that do the job for you. You don't need to bother about.
One question. What does the term project mean, that picture?
The project is the storage of all DTMs that you're using. The topology means to build up the hierarchical structure. And the project means the DTMs at all. So it's separated. One is telling you which is connected to which, and the other one is taking responsibility to the data sets that are in. What else? Not on this picture, but built in some robustness feature which tries to catch a crash that could appear, that could occur. Diagnostic features that let you log the FDT calls, or maybe give you some information about the FDT workflows that are done with the DTM. Just printed out, telling what's going on. The interaction manager finally is the layer between the application and the DTMs that helps you talking to each other. As we have heard, some DTMs are implemented in C++. FDT2 DTMs are implemented in .NET, and this must be covered somehow. This is what the interaction manager does. It encapsulates the DTM itself and provides the proxy to the frame. The surrogate proxies, they are taking care for the .NET common language runtime. Take care for all that has something to do with the CLR. And the data type converters finally does the conversion of the FDT 1.2 XML structures in the FDT2.NET data types and vice versa. So you don't need to do this by yourself. It's all done by the container. Big advantage is that it is more stable inside. We have a backward compatibility to the FDT 1.2.x DTMs and have inside only one kind of data type, .NET. We are exchanging. Makes it a little more easier. What remains left for the application? First of all, there is the user interface. It's not only the user interface of the frame application itself, it's also the hosting of the user interfaces of the DTMs. They need to be shown somewhere. No matter whether they are implemented in ActiveX or in C++, in C# Windows forms or in WPF. There is the database. Database means the storage of the catalog. How information of the data sets of the DTMs are stored. Are they stored in some kind of database? Are they stored in some kind of XML structured files, plain text files, whatever. It depends on the environment the custom FDT application is running in. The container component takes no care about this environment. So when the application runs in a distributed control system, it's not up to the container component, it's up to the custom FDT application, and the custom FDT application needs to take care of it. Communication channels. It's also not up to the container component, it's up to the application itself. Something we have seen in the frames of Schneider Electric. They are coming with communication channels. There are also a lot of other frame application with communication channels. Important for the container component as it finally must deal with a communication channel. But it's not a responsibility of it. And finally, the logging. If you would like to have a look on the logging, your application must provide a possibility to show it. A list which is showing everything that could be shown. The container component provides just the information, but the application must take care for it that it could be shown.